All right, this is an example of a help problem for an application on 5.3 double angle formula. If you're using the Blitzer Pre-Calculus 5th edition, this is page 680, number 69. You are playing catch with a friend located 100 feet away. If you throw the ball with an initial velocity of 90 feet per second, at what angle of elevation theta to the nearest degree should you direct your throw so that it can be caught easily? Now, in this problem, they do give you the formula to use. And the formula they give you is D equals V sub 0. V sub 0 is one variable, it's your initial velocity, squared, divided by 16, equals, not equals, times the sine of theta, cosine of theta. Now, we want to find out what the angle is, so we want to solve for theta. But the first thing I notice is that our theta is in two different trig functions. So right there, that's a red flag that's going to tell me, oh, I'm going to have to find some kind of identity to get it down to one trig function. So I'm going to start looking at what kind of identity I can use. But first things first. The first thing we should do is actually substitute in what we know. D is our distance, and we know we are 100 feet away. So I'm going to replace D with 100. Also, we know our initial velocity is 90 feet per second, so I'm going to substitute in V sub 0 with 90 feet. Now I'm going to start looking for an identity. And hopefully you've started to memorize your identities, but if you haven't, go ahead and peruse your different identities and start looking for one that has both sine theta and cosine theta on one side. And what you will notice is that you have a double angle identity, and we're going to use that double angle identity, or double angle formula, of sine of 2 theta equals 2 times sine theta cosine theta. And this is the identity we're going to use right here. So what this does for us is if we can get this, if we can isolate what we have as 2 sine theta cosine theta, then we can replace it with one that is a singular trigonometric function. Okay? So that's our goal. We want to get 2 sine theta cosine theta on one side of our equation. So let's look at, go ahead and do some multiplication here. Make sure you square first. So 90 squared. So 9 squared is 81. So therefore 90 squared is going to be 8100 over 16 sine theta cosine theta. We want to make sure that we just have a 2 here for the ease of substitution. Don't have to do it that way. You could go ahead and solve for just sine theta cosine theta, but it kind of makes it a little bit easier. So I think I'm going to do that. So when we're looking at this, we want to go ahead and get everything. We want to factor out a 2 so that we can leave the 2 here and then move everything to the other side. So 8100 divided by 2 is 4050. And I'm going to put my multiply by 2 so it balances right there. And so it might take a minute to think about that, on why that will work. But all I did was to factor out a 2 from the 8100. So 2 times 4050 is 100. Okay, so now we want to move this to the other side. So you do that by multiplying by 16 and dividing by 4,500. Do that whatever you do to one side, make sure you do to the other side. And I'm purposefully leaving this in like an unsimplified form so that you can actually see where I'm getting these numbers from. All right. And notice that now that leaves us with 2 sine theta cosine theta on the right hand side. And that's what we wanted. And the reason we wanted that was that will allow us to use our double angle identity. And therefore we can now substitute that for something that has only one trig identity. Because if it only has one trig identity in it, we can solve it. All right. So let's go ahead and do some simplification. We're going to do our substitution first. So now this equals sine of 2 theta. And we'll go ahead and simplify this side now. So the left-hand side. All right. That was my. Let's go ahead and simplify that. And what we want to do is, let me go ahead and get something. Let me go ahead and just rewrite this for right now. Just rewritten, and then we'll simplify in 1 minute. Because I want to show you what I need to do to get rid of the sine function. I need to think about when is that sine function of that angle 2 theta going to be equal to this value. Well, I really don't know, but if I take sine inverse of both sides, I can get at least one of those angles, probably a quadrant 1 angle, since it's going to be positive. So I can think about this process as taking the sine inverse of both sides. Okay, so let's make sure your calculator is in degrees, because I believe that's what they stated. It's in the, and go ahead and do sine inverse of 1600 divided by 4050. And we get 2 theta is going to be approximately, I'm going to round it, but I'm going to take it out 4 decimal places so that I don't really end up with a rounding error. 23.2698 degrees. Okay? That, and I'm going to draw me a little picture and think about this for a minute, because that tells me what 2 theta could be. 2 theta sine is positive, so we have a reference angle of 23.2698, but sine is also positive in not only quadrant 1, but it's positive in quadrant 2. So we have a reference angle of 23.2698. But what is that angle? Well, I'll take 180 minus the 23.2698 and go ahead and subtract that. And that gives me my additional angle. And I'm just carrying this out so that I don't have to worry about a rounding error. I'll round it in the very end. So 2 theta is equal not only to 23.2698, but 2 theta is also equal to approximately 156.7302 degrees. So now they want theta, so I divide by 2 on both sides. So theta is approximately, go ahead and divide by 2, and then you can round it at this point because you're coming to your final. So it's approximately 12 degrees, or theta is approximately 7. 78 degrees. Okay, so I'm hopefully this will help.